I realize this is our third go round, and there'll be a fourth, just for the record. All right, I'm trying to partition this as much as I can to make it beneficial for you. Like if you're here, you do one assignment, and then you do the next one, and then don't want to overload you with the stuff. But today's log equations are going to result in quadratic equations. So yeah, not bad. But the thing we have to start with today is some basic questions like this. Or this. This isn't today's lesson. This is merely necessary knowledge for us to make sense of what's going to happen later in the lesson. So all three of these have the same answer for the record. I've tried to steer you away from using your calculators for logarithms, and I think that I'm fine just continuing to do this. I would just tell you that when the time comes where we do start using our calculators for logarithms, once I teach you how to type these in, if you haven't figured it out already, every one of them is going to return the same answer. And it's going to be undefined. There are times in mathematics, like if you were to grab your calculator, which you don't need to do, but you know, you've experienced this before. If you tried to type in like 4 divided by 0, you know, you get an error message, right? It's like number 1 on the 10 commandments of mathematics, thou shalt not divide by 0. And so in mathematics, there are times when things can't exist, when things don't exist. And for reasons I'll explain to you here in just a second, not one of these exists. Not one of them is defined. Things pop up in math sometimes and we go, that's undefined. Like I can't do that. Kind of like those equations that had no solution. You remember those from fairly recently, I think. Sometimes things just can't be done. And the reason for these being undefined is because if you understand a logarithm, and again, what it means, let's just say I were to put an equals x at the end of this one, because you know that's kind of a pretty common practice when we want to see how something works. What would this say if we did the cycle on it and wrote it out the other way? What would it say? Yeah, thanks, Jared. 4 to the x equals -3. And I would give you all day and offer you 1,000,000 points worth of extra credit. I would make you any deal you want, because the idea is that you can't do this. You think about 4, and if you raise 4 to a really big power, it gets really, really big. If you raise 4 to the 0th power, you get 1. And if you raise 4 to some negative power, what happens? It becomes a fraction, but it sure doesn't become a negative. The argument, you might want to write this down, the argument of a logarithm cannot be negative. And remember, if you've forgotten your vocabulary, let me circle the arguments for you in case you've forgotten what that word means. The -3 is the argument of the log. The -2 is the argument of that natural log. And the -1 is the argument of that log. The argument of a log cannot be negative, because by definition, you can't raise the base of a logarithm to any power that's going to force it to become a negative. So bear that in mind as we reach the end here in a minute or 5 minutes of problem 1, and we do checking our answers. It's something I haven't asked you to do because we haven't really had to, but it becomes imperative today, because if we get answers that make the argument of the log negative, then we rule them out. They're bad solutions, what we call extraneous solutions. All right. So as we get to the end of the first example, I've got 4 examples, and I have you checking. I need you to be on board with the fact that I'm not doing it because I like to boss you around. I'm doing it because we need to weed out the bad guys. And that doesn't mean that I can't get negative answers. To be clear, and I don't know if you want to write this part down or not, I'll leave this up to you. But if I had one of my logarithms in an upcoming problem, let's just say hypothetically, is like the log of x plus 6. Let's just say that's part of a problem that we're about to do. And I wind up with one of my solutions being x equals -2. Don't be fooled and think, oh, you said I can't have negatives. If you put -2 in place of that x, what's -2 plus 6? Right. And the argument of the log then is positive, and we're like, all's well, right? So it's not the answer that can't be negative, it's the resulting argument of the log that can't be negative. Bear that in mind. All right. So again, to summarize, to reiterate, if you didn't write it down, the argument of a log cannot be negative. So what's going to happen today is we're going to combine what we know right now, and we're going to combine it with stuff we worked on a lot back in September and October and probably into November, you'll see. So here's our first one. Again, like I said, 4 examples. I think we will do all 4 today. So we have log base 6 of 3x plus 5 plus log base 6 of 3x minus 4 equals 2. I'm glad we did what we did yesterday before today, because it really laid the groundwork for what this first step is going to be. Just like last night's assignment, what do we have to do? Starts with a C. We have to condense. The thing we want to do, we want to turn it into one of those this to the this equals this equations. You cannot do that until you have a single logarithm is equal to a number. So those double logs on the left have to be condensed into one, and this is where the quadratic is going to appear. So I'm going to show a little extra work here, and it's going to look like this. This is going to condense into one single logarithm, and it's going to be a single logarithm of 3x plus 5 times 3x minus 4. And I'm only using the colored blue brackets just to kind of really emphasize the point that all the stuff in the blue is the argument now of our single condensed log. And then, of course, that's equal to 2. Okay. I haven't asked you to do this in months. Not, we left quadratics back way late, like mid-late first semester, but we're back. So we're gonna re-employ some basic skills here, and we have to do some algebra 1-y kind of stuff, and we have to multiply those 2 binomials together. I don't think, since I was your algebra 1 teacher, that we talked a lot about the word FOIL, right? First, did anyone ever teach you first, outer, inner, last? Did that ever come from someone else? Yeah, I mean, some people use that acronym a lot. They say FOIL. If you watch one of the help videos on Delta Math, you might see him use the word FOIL. FOIL is an acronym that stands for something that you already understand without the acronym. To multiply binomials, you remember this, it's been a long time, that we take the first term of this binomial times the first term of this binomial. So I'm going to introduce that word today. Not a huge fan of it because it gets misused, but throw it out now. So the F stands for first, the O stands for the outer 2 terms of the math problem. And I hope you would identify and agree that if we were to look at the 3x plus 5 and the 3x minus 4, like 4 dudes walking down a tunnel, we would all agree that the 3x and the minus 4 are on the outer edge of the tunnel. So when you hear people say FOIL, this is where that word comes to exist. I'm not showing you anything you don't already know, just giving it a cute little name. So if you ever hear someone say, hey, FOIL that, then you could go, okay, I know what you mean. What do you think I stands for? I already said it. Inner. And again, I look at it as if, again, I use the analogy of the 3x and the 5 and the 3x and the -4 are like buddies walking down a tunnel. I can't help but understand then that the 5 and the 3x are in the inner part of the tunnel, right? They're the innermost 2. And then what does the L stand for? Last. And last comes from 5 is the last guy of this And -4 is the last guy of this. So again, I try not to use it a lot, but when you hear people say, hey, did you FOIL it, or you should FOIL that? Yeah, that's what they mean. So let's multiply the binomial times the binomial. By this point in algebra 2, that should be pretty light work for us. So I'm going to rewrite this now as log base 6 of. I need your help with some basic math. Math is my bugaboo. What's 3x times 3x? It's not 9x. I'm offended by that. 3x times 3x is not 9x. Someone else already tried that. No. It's okay. I'll cut you some slack. It's been a while. For God's sake, no. 3 times 3 is definitely 9, and there's some x's in there. So let's try again. Thank you. It is 9x squared. It's been a while. It's been a hot minute, as the hip kids say. And now we're going to do the outers, right? That's the 3x times the -4, right? What is 3x times -4? In my diagram, that would be the green ones. Minus 12x. Now we're going to do the inners. I've done this, by the way, for the record, 1,000 times. So hope you're figuring out that, oh, I know this already. What's the inner times the inner? 15x. And then the last times the last is minus 20, -20. And then the last thing, of course, that I would want to do is I would want to clean this up before I begin now solving the end of the problem. So I'm going to rewrite this now in its final state as log base 6 of 9x squared plus 3x minus 20. And we arrive at this point. And I really don't want to go on until I'm sure that you're okay with everything that's happened so far. Good, good. Right. Now it's time to acknowledge what this problem actually is. And that is that this is a logarithmic equation that I know, because my teacher said it 1,000 times, I want to rewrite as an exponential equation using the little water cycle diagram. And that means we're going to do this to the power of this equals this. So what is 6 to the power of 2? So we have 36 equals 9x squared plus 3x minus 20. I'm really bringing up some stuff from the past here. We're opening up really old file cabinet drawers here today. Got to brush off the dust. Do you by chance remember what we do when we attempt to solve this kind of equation? This is called a quadratic equation. You would not. It's been a long time. I'm just going to answer this because I don't want to torment any of us. What you do? No. You're following your instincts, and they're all really good instincts. And you're going to hopefully not think I'm crazy, but I'm going to subtract 36 from both sides. The equals, it's not that you can't get rid of an equals. It's going to say 0 equals 9x squared. It's not dumb, plus 3x. Okay, let's just go with that. It's dumb. I acquiesce. It's dumb. So let's do that dumb thing where we set it equal to 0. You hopefully you remember now that it's the cat's out of the bag, but when we solve quadratic equations, we want to get them set equal to 0 so that we can employ one of 3 strategies. The least attractive to you guys, I remember, was probably completing the square. The one that a lot of you kind of fell in love with was the quadratic formula, the -b plus or minus the blah, blah, blah. And of course, the one that I'm a huge fan of is the F word, and that is blast from the past. Not that F word, Carter, factoring, right? And so what we're going to do now is we're going to solve this quadratic equation by factoring it. Everything that I give you today, everything will be factorable. So we don't have to quadratic formula these things. We're going to get in there and we're going to factor. And it's been a long time. So let me remind you now that when I factor this right side down, there are 2 possible things that can happen. Just put that anywhere. One of them, we're really drudging up some memories here today, could be this. Oh my gosh, indeed. It's been a long time, old friend. It's been a long time. You have your 20 seconds of complaining. Let's get it out of our system and then put on our big kid pants and move on. All right, we have to factor. So So we know based on the number at the end, the minus 56, that the numbers are they're either plus minus or minus plus. Like there has to be one of each, right? And remember that we're using pencils here, and we're not really committed to the plus minus because it could turn out to be a minus plus. So just always use pencil. You should always use pencil anyways, but especially with factoring. What's the next thing I do when I factor? Nope. You need two numbers that multiply to make what? 56. So possibilities are, I always like to make a little list over here. I could do the obvious one. It could be some combination of 8 and 7 or 7 and 8. It could be 14 and 4 or 4 times 14. It could be 28 times 2 or 2 times 28. And of course, it could be the dreaded 56 times 1. I feel like our spidey sense would obviously kick 56 and 1 to the curb for reasons you probably remember. And I bet even 28 and 2 shall be kicked to the curb. If you don't remember me saying this, because, you know, it's been 4 months, I like to pick the numbers first that are the closest to each other. I find that I get more wins that way. So I'm going to start with the 8 and the 7. And remember, if 8 and 7 fail, we don't abandon them, we switch them. We say, well, maybe it's 7 and 8, right? So I'm going to take like this one. Maybe it'll work. And if it doesn't, we don't cry. We don't go, well, Mr. Ahern, what's wrong with? No, we try something else. And so we're going to try 8 and 7. And remember, when we try something, when it comes to factoring, trying it is the process by which we say, I'm going to multiply you, and I'm going to multiply you, and then I'm going to add your answers together. And what do I want them to equal? I sure hope they equal 3. And if they don't, we try something else. So the 2 in the middle, what do they make? 24x. The 2 on the outside, what do they make? And what is 24x added to negative 21x? We got it. First try. Theoretically, I mean, mathematically, that could have taken us for like 16 tries, maybe 14 tries or something. We got it on the first try. So, lucky us. Having said that, this is the correct factorization of the equation. And again, bringing up old things. Do you remember what solution we would get from those parentheses? I'm asking a lot of you today. X equals negative 8/3. I put negative. Okay, well, let me do this. Watch the red pen. Follow the red pen. Don't look down. Follow the red pen. Imagine I crossed out that 3. What would make x plus 8 equal 0? What would make x plus 8 equal 0? Minus 8 or negative 8, right? If you put negative 8 in place of x, can we all agree that negative 8 plus 8 equals 0? So that's why the answer would be negative 8. But then, like I heard Sam say, because there was that 3 whoop, in front, then I got to divide by 3. And that's where the answer negative 8/3 comes from. Again, sorry to say this, you've done this 100 times at least. Let's take a look at the other bracket, the other parentheses. Having said that, what solution would we get from correct? Positive, good job, Jasper, 7/3. That was a lot, but we're not done. The first few minutes of today's lesson were there to remind us now that we might have some issues. When you start playing with squares and exponents and you gotta go, oh boy, weird things can happen in math and answers can show up that really aren't supposed to be there. They're like unwelcome visitors. So I'm gonna go back now, and from the beginning of the problem, I want you to remember that one of my logs, you have it right on your paper, said log base 6 of 3x plus 5. And my other log, and I'm not worried about the fact that it said plus, I'm just checking each log individually to see if anything bad happens, said this. Right? I'm sorry to ask this of you, but I am within my rights. You're in an 11th grade math class. I can assume that you know how to multiply a whole number by a fraction. I can also assume that if you don't, that you'll seek me out and say, I need to learn how to multiply a whole number by a fraction. I'm going to take, and I'm going to color code this for you. I'm going to take my yellow answer, negative 8/3, and I'm going to plug it in right there. Any quick rapid fire mathematicians be able to tell me what 3 times -8/3 is, Sam? Which is also known as -8. To make your life a little bit easier, I don't disagree with you, Sam, but to make your life a little bit easier, why don't you just cancel out the 3's when you go to perform that times? You see it, right? The 3 kills the 3 and you're just left with -8. Now let me ask you a real big 11th grade question. What's -8 plus 5? With that said, what can we say about the solution x equals -8/3? It is no good. It is crossed off. I don't have to check -8/3 in the other logarithm, because if it makes any logarithm in the problem log of a negative, it's out. I don't care if it works in the other one at all. If it breaks a rule, it breaks a rule, it's out, booted. Now, having said that, we're going to try, let me color code this again for you. We're going to switch over now and we're going to try the 7/3, and let's see what happens here. If I take 7/3, follow the blue arrow, and I put it right there, what is 3 times 7/3? And what is 7 plus 5? Okay, so we're okay. It passed the first test. Now take 7/3 and put it right here. What's 3 times 7/3? What's 7 minus 4? It passed the second test, so the answer to our first example after all of that is x equals 7/3.
So what if the first one works?
I'm going to say what I said again. If it doesn't work on either logarithm, it's out. Okay, so that's why on the -8/3, the first one I checked it in didn't work. I don't have to check it again. If it fails once, it's out. It has to be. It has to work. It has to make a positive argument in every logarithm in the problem. Does that help a little bit? Sure. Next one. That was a little rough, eh? Glad we didn't try to do this yesterday in addition to what we did yesterday. That would have been a big mistake. I'd never ever want to make anybody cry unless they deserve it. So 2x squared minus 1 minus log base 5 of x plus 2 equals 0. Remember, on the last problem, we had 2 answers, but we had to show one of them the door, right? We had 2 candidates, I guess is how I should put that. One of them stayed, the other kicked out. Condense, right? So I'm going to condense this into log base 5 of what? Let me give you a little hint. Ooh. Look at the yellow thing, it's important. What's this going to condense into? It's going to be over. Good. It's going to be a division problem because the thing that I circled with the little yellow mark, you can't miss that, reminds us that the condensing will be condensed into a quotient, not a product like the last problem. So this is going to be log base 5 of 2x squared minus 1 over x plus 2 is equivalent to 0. I'll just let that sit there and simmer for a few seconds until everyone can kind of go, yeah, I see. We didn't really do anything. Good. We treat these problems a little differently. We don't polynomial long divide the top by the bottom. In a problem like this, we're just going to go right to the water cycle diagram because you'll see why in a second. So on these division ones, we just hop right to it. This to the this equals this. What is 5 to the power of 0? Yeah. So I have 1 equals 2x squared minus 1 over x plus 2. Now, to make what I'm about to do make sense, I have to, I like to do this. I like to remind you that it's very similar to something that you've been doing since the 7th grade. And it goes a little something like this. Imagine I gave you an equation that said 4 equals m over 6. You don't even think anymore. How would you solve that equation? You'd multiply by 6. You would not hesitate. It's in you now. It's part of your like DNA. You know how to do that. We're going to follow the same logic. It just looks a little harder, but in reality, the same principle idea applies. I'm going to multiply both sides of this equation by whatever's on the bottom. And then, of course, on the right-hand side, the payout here is that this x plus 2 and this x plus 2 cancel each other out. Why else would we have done that? You know, duh. And then we wind up with x plus 2 equals 2x squared minus 1. Now, maybe you'll answer this a little bit better than that first one. The first one, I cut you some slack because it had been a few months, but now it's only been about 7 minutes. How are we going to manipulate this equation to get it ready for solvage? Yes, we're going to move the x and the plus 2 over to the left-hand side, because if I didn't say this clearly, let me repeat myself. This is kind of the battle cry when it comes to quadratics. Set it equal to 0, in case you didn't get that the first time. Quadratics should be set equal to 0 when we go to solve them so that we have all of our options available to us. So I'm going to pull the x across, and the 2x squared is going to stay as he is. The x is going to come across and become, well, duh, a minus x. And then we're also going to subtract the 2 across, becoming a minus 3. And there's our goal, our target. We got it set equal to 0. And now it's time, Carter, for your favorite F word. What is it again? Factor. It's time to factor. And this factoring will be significantly less intimidating than the first problem. If you've forgotten why, it's because the number in front is what we call a prime. And when the number in front, the 2, the thing on the x squared is a prime, then I know that V factorization will, not saying maybe, will look like this. Well, that last one, that was a 9, and it could have been a 9 and a 1 or a 3 and a 3. Not this guy. Tell me about my signs. Plus, plus, minus, minus, 1 of each. 1 of each. And it's not because of the negative in the middle. It's because of the negative on the 3 tells me there's got to be 1 of each. So I'm going to just throw them in. If they're wrong, we switch them. Who cares? Plus, minus. And that, even better news, there's not a lot of ways to make a 3. So if 1 and 3 and 3 and 1 don't work, we're kind of out of luck, right? So my spidey sense is telling me, don't put the 3 where that arrow is. Just coming back to you, because it'll power play up with the 2 to make a 6, and then we overshoot the negative 1 that we're trying to make. I think it's pretty obvious that we want to put the 3 here and the 1 here. Now, when we test these, hope it's all coming back to you, the 2 in the middle make 3x. Don't check the 2x squared and the minus 3. We already know that. We only test the ones we're not in control of. The 2 in the middle make 3x, and the 2 in the outside make, and 3x and negative 2x make 1x. But we didn't want 1x. What do we want? We wanted negative 1x, right there where that green oval thing is. So just switch the signs, right? When you get the right number with the wrong sign, everyone is where they should be, just your signs have to change. So instead of plus and minus, we want minus and plus. You don't have to check it because you already know it's going to work. Now, we're back at that point where all of the factoring is done, and now it's time to solve the equation. So again, hopefully it comes back to you from this yellow underlined factor. What is the solution that we get? Now, again, look up here. I'm going to cross out this 2. Pretend the 2 is not there. What makes that set of parentheses, x minus 3 equals 0? Positive 3. So the answer is positive 3, but we have to divide it by 2 because of the 2 in front of the x. What's that? Okay, well, listen. Maybe I didn't hear. Sorry. Okay, how about the other one? Let's underline this guy in blue. What's that one going to be? Negative 1. We good? And I so wish we could just box them up and say we're on to problem 3, but you know, of course, that that's not what's going to happen. We have to check them. And so at this point, I have to recall what my logarithms were. I have a note card here. So my first log was a log base 5 of 2x squared minus 1. My other log was a log base 5 of x plus 2. So let's do this. If we put 3 halves, I'm going to use some color coding here. If I put 3 halves in place of x right there. I'm so sorry that some of you struggle with this. Like, I feel bad. It's just that I do teach an 11th grade math class, so I can't take a half an hour to slow down on what I'm about to do. If you put 3 halves in place of that x, it will now say 2 times 9/4. That's the 3 being squared and the 2 being squared. That's how you square a fraction. And 2 times 9/4 is equivalent to 18/4, which reduced is 9 halves. And 9 halves is the same as 4 1/2. And 4 1/2 minus 1 is what? 3 1/2, which last I checked is a positive number. He passed the first test. Now I have to take the 3 halves and put it right here. And what is 1 1/2 or 3 halves plus 2? Positive also. So this gets the star of approval. 3 halves has passed the test. He is officially a solution. Now we have to do -1, and I shall switch colors. I shall go now in green arrow mode, and I shall say, -1, it's your turn. You are to be put through this battery of tests, and I'm going to put you first right there. And again, you're in high school. You should answer this correctly. What's -1 squared? +1. What's 2 times 1? What's 2 minus 1? That's positive. Check. He's passed the first test. -1 is going to go right here. What's -1 plus 2? +1, which is positive. He has passed the second test. And we now see an example of a problem that has 2 solutions where they both passed both tests. So this time we would put in the delta math, we would either hit the little plus button, or as you know, you can type in comma, and remember how it brings up a second box and you put both answers in, 3 halves and -1. Next one. Holy fat pen, Batman. There we go, that's better. Log base 5 of 2x minus 3 plus log base 5. Oh, why did I put 6? That's not a 6, it's a 5. Oh, bless you. Log base 5 of 3x minus 2 is equal to 0. What do we do? Love that word, condense. All right, so I'm going to get log base 5 of 6x squared minus 13x plus 6. I'm going to give you a moment to kind of vet that. I know you probably trust me, but you should know by now that I'm prone to mistakes just like you are.
So where did the
That's a good question. I did -3 times 3x, which is, no, it's not. God dang it. It's -9. When you say that, it makes me want to punch a baby. That's -9. And you think it's like not a big deal. I know that we all just no big deal. Yeah. Nope. Come do this for a week and you'll see I'm the way I am because of that. What is 2x times -2? -4x. I see you're trying to be funny, but trust me, this is important stuff, Sam. I know what you're going for, but you're missing the mark here. So we got -9x from the middle. We got -4x from the outer edge. And what's -9 plus -4? -13. Does everyone see where I got the 6x squared from? I just didn't show as much work this time. Does everyone see where I got the 6x squared from? Does everyone see where I got the plus 6 from? Then let's move on. All right, so I went a little quicker this time. It's now time to do the water cycle diagram. So we're going to do 5 to the power of 0 equals this. What's 5 to the power of 0? It is 1. So 1 is equal to 6x squared minus 13x plus 6. And at this point is where we must remember those 4 sweet words. 5, I guess. Set it equal to 0. right? It's our thinking, it's our go-to. So who has to move in this case? The 1. Yeah. So we have 6x squared minus 13x plus 5. And there we are at the crossroads. Got here a little quicker this time. This factoring is going to suck a little bit more than the second problem, but a little less than the first, because the 5 in back is going to make our lives a little easier. But the 6 in front is like a bummer, because there's multiple ways to make a 6. And so it could wind up being a 3x and a 2x, or it could wind up being a 6x and a single x. Good news. Tell me about my signs. They're both negatives. Because if they're going to multiply to make this positive 5 in the back, they have to be either both positive or both negative. If the one in the middle is a negative, then they're both clearly negatives. So now we embark on a journey to try to find numbers that multiply to make 5. And pardon the bad grammar, there ain't a lot of them, right? There's 1 times 5 or 5 times 1. So let's just give it a go. A good factor remembers that we don't sit around and, scratch our chins for 8 minutes. We just YOLO this son of a gun and say, let's put a 5 and a 1. Who cares, right? If it's wrong, we don't cry. Does it work? It does. And we know it works because we test it. And if you've forgotten already, which I hope you haven't, what that means is I test these. What do they make? The 2 in the middle. Negative 10x. What do these make? And negative 10 and negative 3 make negative 13, which is exactly what we were going for. So we have our factors, and now we need to find our solutions. What is the solution that will come from the first factor? I heard you say it. Wonderful. 5/3. Nice job. And how about this second solution? 1/2. And now it's time to vet them. My first logarithm had an argument of 2x minus 3. My second logarithm had an argument of 3x minus 2. So let's give them a shot. Color coding incoming. It's time for the red number to run the gauntlet. Here it goes. Zoop. Let's put it right there. What am I waiting for? Oh, those are my logs from the original problem. Look up on your paper about 4 inches. I just didn't write log this time. I was wondering if that would bother anybody. They're just the log arguments. I'm just seeing if they come out positive. That's all. If I put 5/3 in place of x, right there where the red arrow is pointing with the little weird white tip on it, that's funny. What would I get? What's 2 times 5/3? 10/3, also known as 3 1/3. What's 3 1/3 minus 3? Hi, positive. He passed the first test. Nice job, 5/3. Let's move you to the second stage of your exam over there. If you put him in there, what's 3 times 5/3? Stop that. Cancel the 3's. It's 5, right? Stop with the 15/3 and all the 18/2 and the 24/3. Cancel the things out. It's going to happen every time. The 3's cancel, you get 5. What's 5 minus 2? Pass the test. He gets a star of approval. Good job, 5/3. You are in the club. It's time to test 1/2. Switching colors again, 1/2. It is your turn to run the gauntlet. Here you go. You're going in there. What is 2 times 1/2? It is 1. And what's 1 minus 3? It is -2. And for that reason alone, I don't even have to test him in the other one. I can already establish that you, sir, are out. Say what? You said something funny. I'm sorry that I missed it. How are we feeling? Is this easy, Plasma? No, it's not, is it? Let's do one more. I knew we were rocking notes hard today when after my second example, I had to bring up a new page for writing. I thought this is going to be a good day. So yeah, let's do one more. And I wasn't sure how long this lesson would take, but based on the fact that it will officially take pretty much the whole hour, I will extend the due date on the assignment to Monday night, so you can have a work day Monday. So I realized that sending you home to do this would be cruel and unusual, and I am neither of those things. Well, maybe it's tad unusual sometimes, but far from cruel. Lots of twos in this problem. That means we're going to have too much fun.
Okay, no. It would have been a good joke, but not what this, not what we're learning about.
All right. Not too soon. All right, let's do this. Let's get to it. All right. What's his? Sorry. I'm not sorry. Well, I don't even know why I say I'm sorry, because I'm not sorry. You can just take my dad jokes and like them. So what do we get? We got to do that thing, the condensing. Yeah, so we got log base 2 of 4x squared plus 3 over 2x plus 2 equals 2. And I had someone at the end of the lesson yesterday ask, how do you know when to put it over, and and I thought, wow, I failed you if that was your question. Remember, this sign that I'm circling in yellow, that's the key, right? I'm sorry that I dropped the ball there. I'm going to make that clear. If there's a plus there, it's times. If it's a minus, it's divide. Now, this is the one, remember, where we don't actually do the division. We just employ the water cycle and jump right to it. So what's it going to say? You're a step ahead of me. Okay, thanks, Jared. 2 to the 2th is 4 equals. Good. You must first convert from logarithmic to exponential. I'll say that as many times as I have to until you go, okay, I finally heard you. I trust you. Convert from logarithmic to exponential. That's the water cycle diagram part. And now we solve. And now I'm ready for what you said, Sammy. What did you say? Right. It's time for that. It's time to say whatever's on the bottom of that fraction, it's going to get gone. And you don't have to do any math on the right-hand side because, of course, as you know, the entire purpose of that is to just make those disappear. Poof. You got to do a little basic distribution, 7th grade kind of stuff. On the left, what is the answer to the left? 8x plus 8. It's just 4 times 2x plus 2. You're just distributing. And then on the right-hand side, we have 4x squared, oof, plus 3. And those 5 sweet words, set it equal to 0, meaning in this case, I should pull the 8x and the 8 across. So in its final ready to factor state, it'll be 4x squared, and then what? And there it is. All that work to get to here. This is, again, I would venture to say, like, same difficulty level as the last problem. The 4 in the front makes it annoying, but the 5 in the back kind of says, I'll offset the annoyingness of that 4 by making myself a prime and giving you less options here, less stress. So we know, we don't think, we know that the answer will come from either a pairing that looks like this or a pairing that looks like this. So here we go. What do you guys want to try? The bottom one, solid choice. Okay. And of course, there's really no point in wondering, like, hey, where should I put the 5 and the 1? Because it doesn't matter because the 2's are the same. We do have to acknowledge the fact though that the signs are going to be 1 of each. Right? Bless you. And so it doesn't matter where you put them. Let's say we put the 5 here and the 1 here. It's literally the same, minus the signs issue, you know. What do we get? Those make 10x. What do those make? And what's 10 and negative 2? Hey, it's time to, oh, never mind. No celebration. We didn't want 8. We wanted negative 8. And that just means, like Carter said earlier, just got to switch the signs. So instead of plus and minus, we want to make sure the minus goes on the 5 and the plus goes on the 1. And now the balance comes out correct. And when we add those 2 green things together, the negative 10 and the positive 2 make a negative 8, which is what we were going for. We're almost there. What solution do we get from this factor? Yes. What solution do we get from that factor? Negative 1 over 2. And now it's time to vet them. This is the step that you just kind of come to hate the most. The other stuff all will, promise you, become mundane. You do enough of these, you'll go, I get this, I'm good. It's the last step that's just kind of bothersome, and there's no workarounds. You just got to do it. So the first log that I see in the original problem had an argument of 4x squared plus 3. I'm going to ask you a question here, and from the tone of my question, you're going to know that it's rhetorical, but I feel inclined to ask it. Do I really have to check if this works in here? No. I'm not stupid. I know when I square 5 halves, it's going to stay positive, and I know when I multiply it by 4, it just gets bigger positive, and I know when I add 3, it gets more positive yet. So I'd say that 5 halves safely passes the first test. My second logarithm had an argument of 2x plus 2. You see it on your paper, and I'm sorry to ask the same question, but do I even have to check it in there? For the same 4th grade logic, a positive times a positive is a positive, plus another positive is just a bigger positive. So 5 halves, I say you, sir, pass with flying colors. -1/2, we're not going to be quite so lucky. We actually have to do a little bit of math here. So -1/2 is going to go and test himself right there. And again, sorry if this vexes you, but I'll ask, be quick, what's -1/2 when you square it? Nope. 1. No. Yes, it's 1/4. Thank you. You're going to make me give a lesson on that. Square the top, square the bottom. 1/4, and it's positive. And what is 4 times 1/4? 1. And what's 1 plus 3? He passes the first test, and then he will pass the second one too. I agree. If you put him in here, what's 2 times -1/2? -1. And what's -1 plus 2? God, it gets old. It's a positive times a negative. Come on, put your head in the game. That's a -1. And what's a -1 plus 2? It's a +1. And I say you, sir, also pass the test. We need to stop thinking it's cute to miss negatives and positives. All right, no more of that. Be done. Let it go. Sail the ship. Send one of those flaming arrows like they did back the Vikings. Hey, goodbye ship, and just let the I don't know my sign ship sail away once and for all. Good? So there would be 2 solutions to this problem, and that's the end of the notes. Did you enjoy that? No, sorry. My goal for you is this. I'm asking this of you. Don't shuffle around. Don't pack up, because you're going to be the kid that doesn't listen. I would like you to get 2 of your Delta math problems done before I see you Monday. Can you do that? 2. If you don't, I'm going to take that as your way of just saying, no, not interested. Just 2 problems. And you have the rest of today, all of Friday, all of Saturday, and all of Sunday. That's a long time. 2 problems. 10. Right. You'll notice that the assignment has popped up. It popped up about 30 minutes ago on Delta. I will modify the due date to reflect Monday night instead of Sunday night.